Here we're going to look at 2019, question 9, part A. Now, this is a slightly odd question. It's not super hard once you know what you're doing, but it is a little bit weird to get your head around, okay? So this is one where we have one where there's, if we put the same volume, two mixtures together, then we get one density. If we put the same masses together, we get a different density, all right? Now, the first line you can ignore. When the two of them mix, the volume is equal to the mixture of the sum of the volumes. Now, if you ever remember your science and you might have mixed something like alcohol and water, the volumes aren't equal. Okay, they basically little alcohol molecules will drop into the water. You get a lower total volume. That's all what that line is about. So you can essentially ignore it for our purposes. Okay. Now, the thing to remember is, of course, our density equation is mass over volume. So we can relate these by saying, well, the mass equals rho v. All right. So if we look at the first situation here, where the volumes are equal, the mass has got to be different, because we're kind of assuming for this question here that the densities are going to be different. So it's more often, if they ask for the volumes, so the volumes equal, we're going to relate that in terms of mass. And when the masses are equal, flip this around, and we're going to relate that in terms of volume. That's the key to this whole thing. Okay? And the reason we do this is because you can see I now have this in terms of density, and I have information about densities. So if the volumes are equal, the mass of A plus the mass of B is going to equal the mass of the total. Okay, we'll just move our focus here so it doesn't keep jumping on us. Now, let's convert to rho v, and then we have rho A v equals rho B v. Okay, and this is the density of the total, and that's of course 2v, because the volume of the first one is the same as the volume of the second one. Oops, sorry, that should be a plus. Apologies. And they're equal, that's 2v. So now we've knocked a variable out of the whole equation. Okay, what do we know this one? The relative density of the mixture is 800. Okay, so you can either stick in relative densities or you can go to normal densities. What we'll say is, we are looking for the relative, let's convert everything to relative density. All right, so we know here that rho equals S by 1,000. Okay, so if the density of water is 1,000, the relative density of water is 1. So we just convert, we can divide everything by 1,000. So it's going to end up being SA V plus SB V equals S of the total by 2V, and that equals, we know this, 0.8. 0.8 by 2V. Okay, now I can cancel my V's. This becomes more interesting. So SA plus SB is 1.6. Now I have something I can use. Okay, so let's go to the other one. The mass is equal. So we are going to relate that in terms of, so rho equals mv over v. So therefore the mass, the volume, bring that up, bring that down, equals the mass over the density. Okay, and that equals the mass over 1,000 times the relative density. So that's what we'll use. I think we'll get one line in here and we'll go back up the other side. So what do we know in this one? Well, equal mass of the same substance are mixed. Okay, so we can say the volume of A plus the volume of B is a total volume, and that means, converting this over here, M over 1,000 S plus SA. We're just gone off screen here, bring this all the way up here. Okay, so we have the mass over 1,000 SA plus the mass over 1,000 SB. It's the volume of B. The volume of the total, well, it's 2M over 1,000, and we're given this 0.6. Okay, lose our thousands, lose our M's. Let's do a bit of tidying because that's two cancellations. So I get 1 over SA plus 1 over SB equals 2 over 0.6. Now, if you're just, I'd sort this out, I think, at this stage, and just throw it in your calculator. See if we can see our calculator there. There we go. 2 divided by 0.6, 10 over 3. Okay, just a little bit easier to get that sorted out. And I wouldn't be trying to do that in your head in an exam. It's not worth the stress and hassle. Now, this is not particularly useful the way we have it here because of the denominators. Okay, so I would prefer a common denominator, which of course is going to be SASB. So that is going to end up being SB over SASB. I'll just make that a little bit cleaner. SB over SB plus SA over SASB, and that equals 10 over 3. Tidying up, SASB plus SA. Now, where can we go from here? Where can we go from here? Well, let's have a little think about this one. What have we got that we can kind of work on? What we know is that that's 1.6. Okay, so we'll take this, and that equals 1.6 from here. So let's do that, and we'll bring some of these guys across. So we have, I'm going to multiply across first. It's 3 factor of SA plus SB equals 10 SASB. So that's 4.8 equals 10 SASB. Now, okay, we're getting there, but we still haven't quite got this solved yet because I still got 2 variables. However, using this guy here, I can say therefore SA equals 1.6 minus SB. So let's sub this in. So now we have, we'll get rid of the 10 over here, so that I'm going to have 0.48 equals, I'm subbing in SA, so SB, factor of 1.6 minus SB. And equally, because it's subbed in SB, it doesn't really matter which way you do it. Okay, let's multiply this out. 0.48 equals 1.6 SB minus SB squared. And I'm sensing a quadratic. Now, if you think about this, quadratic means 2 solutions. Okay, now sometimes when we get these ones, one will be negative, like a negative density doesn't make sense, and that might solve it. But actually, in this particular type of question, who's to say SA is one of them is SA and the other is SB? So if we flip the liquids, let's say the brown liquid and the green liquid, we decide the brown liquid is SA, we get one solution, but if we decided the brown was SB, we'd get the other. So we're going to find 2 solutions and they're going to flip around. Now, if that doesn't make sense, don't worry, we'll power through and it'll make sense at the end. Let's line it all up. SB squared, bring this over this side, minus 1.6 SB plus 0.48 equals 0. Now, don't freak out just because they're decimals. Again, minus B will always solve it, but I would begin to just pause and think, if just even in your head, think of these as kind of normal numbers like 48, 16, what's in common, factors of 48. Well, I'm kind of thinking 4 by 12, and if we convert these down here, we'll see this actually solves itself quite easily. SB, okay, it has to be that because there's nothing else there. And if we had 4 and 12, that of course becomes 0.12 and 0.4. 0.04, apologies, let's scribble that out. I know, 0.4. 0.4. Okay, what are we going to get if we bring this together? 0.4 by 0.12 is 0.38, and 0.4 SB plus this needs to be 1.2. So I'm just going to do a little bit of a scribble there. Yeah, and we can work out those kind of decimal places as we go. SB, and that is 1.2, that is 0.4. 0.4 by 1.2, and check this kind of thing in your calculator. If it's awkward with the decimals, 1.2 by 0.4. 0.48. So now we're golden. Of course, those two together equal 1.6. Now I think about signs. Minus by minus is plus. Yep, signs are correct. And therefore, SB, we'll just about get this in. Oh, we're going to lose a page. I'm going to come into the center here just so we don't have to, it's the final bit. Therefore, SB equals 0.4 or 1.2. All right, and you can see here, of course, these two together are 1.6. All right, so we want to find the relative density of the substance. So therefore, relative densities. (0.4) and 1.2, and we just don't care which is which.